Alright, here we got a diamond of AGS cut quality 0. We're going to be looking at the table and trying to keep the crown angle and the pavilion angle constant. So right now the table diameter is at 53%, and here we got the HDR rendering of the diamond. What we're going to do first is that we're going to see how it affects its fire by changing around the table. So what we're going to do is that we're going to split the diamond to the side view, and we're going to do a wireframe, and we are going to add a ray tracing into the diamond. Alright, so this here, as you can see, my mouse pointer would be the crown, and this would be the pavilion. Alright, and this would be light coming in from the top to the table and coming out from the crown back to your eyes. Okay, so this would be at a 53% table diameter. Right, so if you move the light around, this is how you see it's going to be affected. Okay, and this is when light escapes from an angle and not back to your eyes. Okay, so right now at a 53% table. Now what we're going to do is we're going to increase it to 60, and as you can see, light is escaping in this way. So what this means is that because of the interaction between the crown and the pavilion, it produces that good amount of fire, and naturally a diamond with a smaller table would mean there's more interaction between the crown and the pavilion. Okay, as you can see, light coming back this way. Okay, so if we move this around, move the light around, we have a larger surface area of the crown producing that nice amount of fire and brilliance. So a smaller table definitely increases the amount of fire. So you see in the diamond as well as scintillation due to each facet on the crown being much more readily seen from the top view. You can and the larger amount of the larger facet sizes on the crown produces the higher amount of scintillation that you get back to your eye. Okay. So once again, increasing the crown, increasing the table size. Right, leaves you very little room on the crown section, and less interplay between the crown and the pavilion, which means less fire, as well as the smaller facets and the smaller region that you're able to see on the crown facets would mean less scintillation. Okay, so how does this affect a diamond through the Ideoscope based on table size? Firstly, we're gonna switch back, and we're gonna have a look at the Ideoscope. Okay, so this is an Ideoscope of what you see on AGS cut quality 0 with a crown angle of 34.5 and a pavilion angle of 40.75 with a table diameter of 53%. Now what we're going to do is take note of these arrows, okay, and what we're going to do is increase the table size once again. Alright, all the way up to 60. If you notice, now the contrast patterning in the arrows starts, the arrows basically start becoming thinner as you compare to this, as it's thicker and bolder. What happens is that a diamond like this would appear, the contrast will appear blackish in a real-time environment. Let's see how, let's compare this on the HDR setting. There you go. Okay. All right. So these are basically the arrows that you see in the Ideoscope. They appear as blackish or contrasted, and the reds will appear as whitish or grayish through the Ideoscope. Now, what happens is that these areas of redness produce that brightness in the diamond. Okay. So with a 53% table, this is the amount of brightness that you're going to see, minus the contrast patterning in the diamond. All right. Let's put back on the Ideoscope. Okay, now when we increase the table size, if you notice, the arrow starts becoming smaller and thinner. That's where contrast becomes less, and you have that more areas of red, which produces a more amount of brightness in the diamond as well. This can be a good thing and a bad thing. You know, the table is too high, too big a diamond with too big a table size to start producing. You see these light leakages in the diamond. Okay. As well as if you notice, the contrast patterning is not as black and bold anymore, which produces that, you know, it starts looking brighter, with the sacrifice of course, iron scintillation. Okay. Right. So now if you notice, it starts becoming less contrasted. There's brighter areas in the diamond, and basically a less amount of fine scintillation, which you will see later when we start rendering this in a swinging pattern, so you can see that how it reacts under a spotlight environment. Okay.